Good morning, ma'am.
Morning. Ka-exam na mo tanan, exam sa Electromag.
O, duha pa yata among na-examan, ma'am, ay.
Okay. Okay, so mag-start na ta without the others kay kuan kanang para mahuman na to ato ang kuan discussion karon. Anyway, this is recorded so they can watch pag maka-upload na ko sa video. Okay, so our last topic for chapter 1 is the Dirac delta function. Madunggan ako ninyo, July.
Yes, ma'am.
Okay, so let us start with the divergence. Okay, so we will start with the divergence of this function. This is a vector function. And this vector function is familiar because we had this in our previous examples. So from here, consider this function. So that is our vector function. We have 1 over r squared r hat. Okay, so this one. Muna siya nga function, no? 1 over r squared r hat. Now, at every location V, kini si V class is directed radially outward. So, mag-ingan niya ang direction. It is directed radially outward. So, as you can see from this figure, we can tell that, or from this figure alone, we can tell that this vector function has a positive increasing divergence. Okay, so from this figure, we can tell that kini siya nga function class has a positive increasing divergence because as you can see, it diverges from a point, no? So nag-diverge siya from a point, sorry. It diverges from a point, this one, this point P here, and then it is positive because it is radially outward, and then it is increasing. Okay, however, if atong paunang divergence ani, ganyan divergence, the divergence of this vector function, we will get 0. Ano ganitong 0? So this is the evidence. So naay somewhat like a paradox ani nga vector function, no? Murag na-discuss naman ni siya nato last time nga pag imo siyang i-graph, you can see this one, it has a positive increasing divergence. However, if you actually get the divergence of this vector function, like say for example, this one, no? The divergence of V is equal to, for spherical coordinates, you have 1 over r squared multiplied by the partial derivative of r squared times the r component, the radial component, which is 1 over r squared. Okay, so here we will get a constant, r squared over r squared is just equal to 1, so the derivative of that is equal to 0. Okay, so as you can see from this, so this is the evidence that the divergence of this vector function is equal to 0. So again, na a discrepancy between these two. Now, also, if we apply, maragi try man na to apply ani ang divergence theorem, no? So if we apply the divergence theorem, sa ganitong divergence theorem, Bernadette, you have the integral of the vector function with respect to a volume, or the volume integral of the divergence of a vector function is just equal to the surface integral of that function with respect to some surface. Okay, so this is the divergence theorem. Now, if we calculate the divergence theorem, so the left-hand side would give us 4 pi. And then the right-hand side will give us 0. So this is not, they're not equal. So from the divergence theorem also, we can say that there is a discrepancy, or between the left-hand side and the right-hand side of the divergence theorem. Okay, so may meaning ani class. So this, we can say that the divergence of V vanishes everywhere except at one point. Or that means the divergence of 1 over r squared, r hat, is equal to 0 everywhere except at one point. Okay, so what we have encountered is the Dirac delta function. Okay, so let us write the one-dimensional Dirac delta function. Dirac delta function. Okay, so the Dirac delta function is denoted by this. Okay, and we have this one. This is equal to 0 at x equals 0. This is equal to 0 at x not equal to 0, and this is equal to infinity at x is equal to 0. Okay, so this is the one-dimensional Dirac delta function. Ano may meaning ani class? So this can be pictured out as an infinitely high, infinitesimally narrow spike with area equal to 1. Okay, so for example, nakadiri sa x-axis, no? X-axis. Okay, so if you have the Dirac delta function, this one is your 0, the origin. So at x equals 0, its value is infinite. And otherwise, it is 0. Okay, so magiging ani class. So it has an infinitely, narrow spike at x equals 0. Okay, so infinitely high, infinitesimally narrow spike, infinitely high. Let me just write it in red. Infinitely high and infinitesimally narrow spike. Okay. Now, if you integrate the Dirac delta function, so if we integrate this one over all space, then we will get, so you have integrating this from negative infinity to positive infinity, we will get 1. Okay? So technically, the Dirac delta function is not a function. So technically, it is not a function, but you can consider it as a distribution. So it is a distribution. Okay. Now, if you have an ordinary function, so this is the Dirac delta function. Now, we have, if f of x is an ordinary function, okay, then f of x multiplied by the Dirac delta function is equal to 0 everywhere except at x equals 0. So this one, kinesia class, if you multiply an ordinary function with the Dirac delta function, it is equal to 0 everywhere except at x equals 0. Okay? So it follows that f of x multiplied by the Dirac delta function is just equivalent to f of 0 multiplied by the Dirac delta function. Okay, so meaning to say, this function is just equal to f of 0. For example, ano yung meaning aning f of 0? So, say for example, if you have f of x is equal to x squared plus 2, for example. So, if you multiply that with the Dirac delta function, ang iyang answer class is just equal to f of 0 multiplied by the Dirac delta function. So, kung sa meaning ani f of 0, you just have to replace or substitute all of the x's here with 0. If we integrate multiplied by the integral of Nawala ang connection sa department class, magani kinibalik. Shall we continue? Okay pa mo dira?
Yes, ma'am.
Okay. All right, so we have this one. If we integrate f of x multiplied by Dirac delta function over all space, this is just equal to f of 0 multiplied by the integral of the Dirac delta function over all space. Now, we know that
Wala may makita.
wala may makita. Okay, okay. Okay na? Okay. So again, integrating this function multiplied by the Dirac delta function over all space, this will give us f of 0 multiplied by the integral of the Dirac delta function over all space. Now we know that kinisha is just equal to the integral of the Dirac delta function over all space is just equal to 1. Therefore, this integral here is just equal to f of 0. Okay? So, we can also shift the spike. So, we can also shift the spike from x equals 0 to, say, for example, x equals a. All right, so if you have this one, this is your origin, this is 0. And then, say for example, muna siya imong A. Alright. So, you can shift the spike here. Like, for example, nadiri mong infinitely high, sorry, infinitely high, infinitesimally narrow spike. Okay, so we can shift the spike from x equals 0 to x equals A. So, by doing that, we will have the Dirac delta function. You can write it as this. And it has, again, it has value equal to 0 if x is not equal to a. And it is equal to infinity if x equals a. Okay, so it only has a value if x is equal to a. Now, if we integrate this function over all space, so integrating over all space, so that means you have to integrate it from negative infinity to positive infinity. Again, you will get 1. Okay? So, that if you have a normal function f of x, multiply it with the Dirac delta function, this is equal to f of a multiplied by the Dirac delta function, you have this one. And if we integrate this over all space, so this is just equal to f of a multiplied by the integral of this function over all space. Okay, which we know that this is just equal to 1. Therefore, the integral of f of x multiplied by the Dirac delta function is just equal to f of a. Okay? So you just have to evaluate the function for x equals a. So muna siya ang meaning ani nga integral. Now, two expressions are considered equal. So two expressions involving Dirac delta function are considered to be equal. Are equal if you get the integral over all space of that function. So you have this one. Okay. So these are two expressions involving Dirac delta function, and they are considered equal if you get their integral over all space, pareha ilang integral over all space. Okay? So for example, para ma-visualize na to class, let us have some examples. You have this one. Evaluate the following integrals. Okay, so the first integral is this. You have the integral of 3x squared minus 2x minus 1 multiplied by the Dirac delta function x minus 3 delta of x minus 3 dx. Okay, so let's try to evaluate this one from 2 to 6. Okay, so according to our according to this one, you have the integral of f of x multiplied by a Dirac delta function. This is just equal to f of a. So as you can see here, our a is 3. So ba? So this is our a. So you can rewrite this as, this is your f of x. Kini siya, no? Kining black. This is your f of x. And then this one is your a. So a is equal to 3. So you just have to evaluate f of x for x equal to 3. So yun na siya evaluate class. Like for example, this one. This is just equal to 3 multiplied by 3 squared minus 2 times 3 minus 1. So you have 9 times 3, 27, minus 6 minus 1. So 27 minus 6 minus 1, that is 20. Okay? So, di ba, ang usual na to nga ginabuhat is to integrate this from, integrate siya na to, no? Kini siya nga function, but since you have this function multiplied by a Dirac delta function, then you just have to evaluate this function for x is equal to 3. Okay, nakuha ninyo, class. And then, let's have another example. So, we have another example. Cosine x, and then you have the Dirac delta function x minus pi. So, nakay delta of x minus pi dx. So, this is evaluated from 0 to 5. Okay, so here we can have so ganito na siya. So you have pi. A is equal to pi. Therefore, you just have to evaluate cosine x. This is our function f of x, right? So this is just equal to f of pi. So your f is equal to cosine x. So you have cosine pi. So pila ning cosine pi, class? Cosine 180 degrees, that is equal to -1. Okay? So dali ra kayo na mag-evaluate og integral kung nag-involve siya og Dirac delta function. So you just have to evaluate it at x equals a. Okay, so let's have another example. So you have from 0 to 3 x cubed. You have x plus 1. Okay, now, so kaganina, no, for our first example, so for our first example, as you can see, our limit is from 2 to 6, okay? So our A is equal to 3. So the value is within the limit. All right. And then here, our A is equal to pi, which is equal to 3.14, right? And our limit is from 0 to 5. Now we have here a function, an integral from 0 to 3. You have x cubed multiplied by the Dirac delta function, so delta of x plus 1. Now, I want you to note kung unsa ang value ni A. Ano yung value ni A, ani, class?
Dili man, ma'am.
-1, ma'am.
Yeah, it's -1. So, naakay x equals -1. Nga na ganing -1 kay ang atong Dirac delta function kay x minus a man to siya. So, nalang ni siya value at x equals a. So, if you have x plus a ang nakabutang dire, then that means ang imong x is equal to -a. Okay? So, this one, is it in the limit? So,
No.
we will be tempted to evaluate this. Kini siya, no? X cube. So, nakay -1 cube. So, we will be tempted to evaluate this one. But as you can see, your x, the value of your x is not in the limit. Therefore, the integral is equal to 0. Okay? Nakuha ninyo, class?
Yes, ma'am.
All right. And then, last example. How about this one? So you have the integral of ln of x plus 3 and then multiplied by the Dirac delta function. This is from -infinity to +infinity. Okay, so for this, you have a equals
-2.
-2.
-2. So you have a equals -2. Therefore, It is in the limit because it is integrated over all space. So you have ln of, evaluate lang ni siya na to, no?
Negative 2.
Negative 2 plus 3. So you have ln of 1. Pila mo ni ln of 1, class? ln 1 equals
0.
0. Okay. So ln 1 is equal to 0. Okay, so ingani ka beautiful ang Dirac delta function. Okay, now we have this one here. Take note that sige ito. You have the integral of f of x times the Dirac delta function. Say for example, nakaingani no, k of x, kx. So delta of kx, where k is a constant. Okay, so if you integrate this over all space, then we have this one. The integral of f of x multiplied by 1 over the absolute value of k. So again, k is any constant, multiplied by the Dirac delta function, the one-dimensional Dirac delta function. Okay. Now, we can take this out. So remember nga, pwede na siya na to ano? Since this is a constant, we can take this out of the integral sign. And then we are left with katong original nga, so nakaingani no? 1 over k. And then the integral of f of x, you have delta. Okay. Now we know the value of this one. So this is just equal to 1 over k. Unsa ganin ni siya, class? This is equal to f of 0 lang. Okay? So if you have this function, f of x, if you integrate this one, f of x multiplied by the Dirac delta function, delta of kx, it is just equal to this. So take note that Dirac delta function is an even function. So siya cosine ba na? Cosine negative. You have this one is just equal to this. Okay? So please take note of this. Ngano ganito? Since this one naman kay negative 1 o negative 1 man ni siya. So you have your absolute value of k. So 1 over negative 1, absolute value of negative 1, you will get 1 multiplied by f of 0. So you will get the same as this one. All right. So we will have another example, class, and then we will have the three-dimensional Dirac delta function. Apo ba tayo time? I discuss na ako una ang three-dimensional Dirac delta function, and then I have to mag-example. Okay, so how does a three-dimensional Dirac delta function looks like? So you have 3D Dirac delta function. Okay, so you can write it this way. So you have delta cube of r. Okay, so this is equal to this. Delta of x times delta of y times delta of z. Now, this is 0 everywhere. 0 everywhere. Except at, what's ang value, class? Except for x equals 0, y equals 0, and z equals 0. Okay, so the 3D Dirac delta function is 0 everywhere except for x equals 0, y equals 0, z equals 0. So basically, this is at the origin. Now, its volume integral is equal to 1. So if we get the volume integral of this, overall, the volume from negative infinity to positive infinity, so ito makuha, class. Sorry, this is d tau. So you have a triple integral, negative infinity to positive infinity. So this is a triple integral, but eventually you will get 0. So you have dx, dy, dz. So eventually you will get 1. Sorry, 0 akong dimension ko kanina. Okay, so in general, so if you have a three-dimensional function, we can generalize it. So kaganina, one-dimensional man to, no? In general. So in general, if you integrate a function, an ordinary function f of r, multiplied by the Dirac delta function, the three-dimensional Dirac delta function, over all volume. So this is just equal to the value of the function at r equals a. Okay? So integrating this over all space. Any questions so far? Okay,
Yeah, no.
now, recall, so, ganina di ba nag-start with the divergence of the vector function. Nakainga nga vector function 1 over r squared r hat, where its divergence is equal to 0, no? So if you get the divergence of 1 over r squared r hat, you'll get 0. But kung imo siyang integrate, if you get the integral of this function over all volume, ang atong makuha kay 4 pi. Okay. So, these are the defining conditions for the Dirac delta function. Okay, so we can rewrite this as defining conditions for the Dirac delta function. Sa uban nga book class, kini siya kay nani siya tawag murag solid angle. Solid angle. Okay, so the defining conditions for the Dirac delta function, you have the divergence of 1 over r squared r hat, 1 over r squared r hat is equal to 4 pi multiplied by the three-dimensional Dirac delta function, which we know nga kung ato ni siyang i-integrate ni siya nato class. Kung sa ito yung value, it is equal to 4 pi. Okay, so in general, more generally, you can change this one. Kining R diri, i-change ni siya nato into the separation vector R. So, pwede siya nato isulat as this. You have the divergence of the separation vector 1 over the separation vector R squared. R hat is equal to 4 pi multiplied by the Dirac delta function. Okay? So, again, kini siya no, ang Dirac delta function only has value for R is equal to 0. Kini siya no? It has value for R is equal to 0, or if R is at the origin. Sorry, this should be written as the separation vector R. So recall that the separation vector R is just equal to R minus R prime. So R being the, so ganun siya class, the source point, and then R prime is the field point. Okay, now, incidentally, since, example ba ni siya nato class? I think nahatag ni siya nako as an example. Di ko sure, but this is just equal to the negative of 1 over R squared R hat. Okay, so the gradient of 1 over R is just equal to the negative of 1 over R squared R hat. I do not know if this has been given in the previous example, but you can take note of this. Pwede po din siya na to i-prove. Okay? So it follows that the Laplacian of 1 over R is equal to the negative of 4 pi times the three-dimensional Dirac. So, this one, the gradient rather. Okay, so you have this one. Okay, so you have, so the gradient of 1 over R is equal to the negative of 1 over R squared R hat. Now we know that the gradient of 1 over R squared R hat is equal to this one. So if we take the gradient, of this function, if you get if you take the divergence of this function, it is just equal to what in your class? So if you get the gradient, the divergence of this function here, kuha ni mo divergence ani, mura pag kag nagkuha og divergence ani, so you will get the Laplacian of 1 over R. So that is just equal to the negative of 4 pi multiplied by the Dirac delta function. Okay? So again, gikuha lang na to ang divergence ani no, both sides of the equation. So here, the left-hand side, you have the Laplacian of 1 over R. So this is equal to the negative of this, the negative of this one. Okay? Any questions, class? I do not know if klaro ba to siya? Let me have your feedback and comments or any questions so far.
Apil ni sa exam, ma'am?
Yeah. Okay. So shall we have Some examples. Class, napatay time, 20 minutes. Okay, so for example, evaluate the integral. Okay, so you have a function j, which is equal to the integral of r squared plus 2 multiplied by the divergence of r squared over r. Okay, so you have this function, I have this integral class. So this one, kini siya nga part, we can consider this as your f of r. So this is your normal function. And then this, kini siya nga part, kini siya factor. This is actually equal to 4 pi times Dirac three-dimensional Dirac delta function. Okay, so let us rewrite this. You have r squared plus 2 multiplied by 4 pi times the three-dimensional Dirac. Okay. So you have 4 pi. You can take this out of the integral. And then what is left is this, no? So we will integrate this over all the volume. So ang nasa sulod sa integral sign is r squared plus 2 multiplied by the three-dimensional Dirac. Okay. Now, in order to evaluate this one, kini siya nga integral, balikan na to tong ato ang generalized nga equation. So you have this one. So if you have f of r multiplied by the 3D Dirac, you just have to evaluate the function for x or for r equals a. So in this case, our a is equal to 0. Diba? Our a is equal to 0. Therefore, you have 4 pi multiplied by f of 0, where f of 0 is equal to 0 squared plus 2. So this is just equal to 8 pi. Okay? So yan na lang siya kasayon. How about this one? So another example. So you can do this on your C's class. How about this one? I'll give you 3 minutes to solve this integral. So integrating over all the volume. It's the answer. So you have e to the negative r integral of e to the negative r multiplied by 4 pi times the three-dimensional Dirac. So you have 4 pi multiplied by e to the negative 0. Ilagay ng e to the negative 0, class. Is that equal to 1? John Paul? Do you have your calculators with you? E to the negative 0 is equal to 1, right? Ito ba? So this is just equal to 4 pi. Kindly check lang ha kung may value sa e to the negative 0. Alright, do you have any questions so far, class? So I guess this is the end of chapter 1. So first I will just give you a set, and then after the problem set, and our quiz next week. Okay, do you have questions? Do you have questions?
Ano sa itong, ma'am? Napapul-papul mo naman ka na sa itong exam, ma'am?
Exam will be next week. Wala pa concrete na schedule, and then if ever I'll be able to give a problem set for you to work on this week. So ako siyang ipasubmit by Friday.
Okay, ma'am.
Okay,
Okay,
someone
ma'am.
raising her hand. Ano ba ito raise of hand? All right, and then this one is your assignment. Okay, so you have okay, so you have three items, class. So this one is from 0 to 2, negative 2 to 2. The last one is from negative 1 to 1. Okay, so please solve this one. By the way, this is 9. Okay, so please write this on a 1/2 sheet of yellow paper to be submitted within this day. Ibilin lang ninyo sa akong table, class. Okay? So, do you have questions?
None so far, ma'am.
Okay. So, see you on Thursday. Unsa ta sa Thursday? Discussion lang gyapon, class. We will have chapter 2. Okay? We will start with chapter 2. Online. Okay, so see you. Bye-bye.
Bye, ma'am. Thank you, ma'am.